In section 3.1, we're going to be solving systems using tables and graphs. When you have two or more related unknowns, you may be able to represent their relationship with a system of equations. In this section, we're only going to be looking at linear equations, therefore we call that a linear system. Further, a solution to the system is a set of values that make that system true. So on a graph or visually, if I graph both of those linear equations, the solution is going to be at that point of intersection or where those two equations meet. On a table, if I look at a table of both of these graphs or equations, I'm looking for the point where I have the same input, or for the input value, I have the same output value. The first problem we're going to look at is using a table or graph to solve a system. So they gave us two linear equations and they want to know what is the solution to this system. So the first method that we're going to look at is by graphing it. So to graph it, both of these equations right now are in standard form. It's going to be easier to graph it if we have it in slope-intercept. So for this first equation, to get it to slope-intercept form, I'm going to add my 3x on both sides to get the y by itself. And then finally, I'm going to divide everything by 2. And I'm left with y equals 4 plus 3 over 2x. So now I can easily see for graphing it, I'm going to start at 0, 4, count up 3 over 2, and then go the other way. And there's my first line. To graph the next equation, again, I want to get y by itself, so I'm going to subtract the x on both sides. I'm left with 2y equals negative 8 minus x. Divide everything by 2 again, and I'm left with y equals negative 4 minus 1 over 2x. So to graph this, I'm going to start at negative 4 and then go down 1 over 2. So now I can see that my graph is intersecting at this coordinate. So the solution to this graph is negative 4, negative 2. If I wanted to look at a table for this same problem, if I plugged both of these equations into a table, it would look something like this. So similarly, on the graph, we saw that when I had the same input of negative 4, I got the same output of negative 2. On a table, it would look like this. So I input negative 4 in both equations. It's a solution and they intersect because the output for both of those equations is negative 2. So that's why they intersect there. So finally, you can classify a system of linear equations by the number of their solutions. So what we just looked at was an equation with one solution, but there's also two other situations. You could have one solution, as you can see on the left. Coinciding lines is when you have like the same line, so one line on top of each other. You might remember that from Algebra 1 as infinitely many solutions. And then finally, if you have parallel lines, they never intersect, so that would be no solution. In Algebra 2, the vocab that we're going to use for this is if it has one solution, that's considered consistent independent. If I have infinitely many solutions, I would call that a consistent dependent system. And finally, for parallel lines, you would call that an inconsistent system. So finally, we're going to look at classifying a system without graphing. So just by looking at these graphs or looking at these equations and kind of like comparing their slopes and their y-intercepts, we're going to be able to determine whether a system is independent, dependent, or inconsistent. Independent means one solution, dependent, infinite, inconsistent, no solutions. So for both of these lines, again, what I'm going to want to do is get this into slope-intercept form. So for this first one, I'm going to add 2x to both sides. And then I'll divide everything by 4. You could leave that as 6 over 4. I always like to simplify it. So 1.5 plus 1 over 2x. For my other equation, all I really have to do is divide everything by 8. So I'm left here with y equals negative 12 over 8, or 1/2 x minus 12 over 8, which is 1.5. So here I can see that I have the same slope but different y-intercepts. My slope for this line is 1/2. My slope for this line is 1/2. Therefore, I know that these lines have to be parallel, but the key here is that they have different y-intercepts. My y-intercept for this first equation is 1.5, while my y-intercept for the second equation is negative 1.5. So if I graph these, let's say positive 1.5 is here, my slope. Here's the first equation. Second equation will be somewhere in the negative here, but it'll also have the same slope. So when I have a situation like this where I have the same slope but different y-intercepts, that tells me that these are parallel lines, and also, more importantly, that they're never going to intersect. So this would be an example of an inconsistent solution, or an inconsistent system.